Hello everybody, my name is Mauricio Lopez Cruz and I'm going to present my project entitled Synthesis and Magnetic Characterization of Novel Hard Magnetic Terbium Cobalt Nickel Alloys. In this project we are going to see the synthesis and the structural magnetic characterization of these ribbons alloys, which were synthesized by Mel spinning, and they were characterized their structural and magnetic properties. The motivation of this work has come because of development of high-performance permanent magnets for cryogenic applications remains a major challenge in modern material science. Rare earth transition metal intermetallic compounds are attractive candidates due to their exceptional magnetocrystalline anisotropy and high coercivity. However, conventional processing routes generally require long annealing treatments and achieve the desired magnetic performance. In this work, these alloys ribbons were synthesized by rapid solidification, in specific with the Mel spinning technique, providing a simple and efficient route to obtain a highly crystalline material with outstanding hard magnetic properties, including high coercivity, large remanence radio, and high maximum energy product. These characteristics make these alloys a promising candidate for next generation cryogenic permanent magnets. Now I'm going to show how the ribbons alloys were obtained. First, the master alloy was fabricated by arc melting using the required stoichiometric amounts. It means elements with more than 99.9% of purity and under a high purity atmosphere argon. Then, these 3 grams of alloy was melted and remelted several times to ensure chemical homogeneity. Subsequently, Mel spun ribbons were produced using a Mel spinning system. That's how rapid ribbons alloys were produced. These are the characterization techniques we use to study these samples. The structural characterization was carried out with X-ray diffraction, and the magnetic properties were analyzed with a PPMS with VMS option. Now I'm going to present the results of this project. In the figure 1, we have the X-ray diffraction patterns measured at room temperature. The diffraction peaks indicate that these alloys crystallizes in the tetragonal structure. In figure 1, we can see the thermomagnetic curves measured under an applied magnetic fields of 5 milliteslas. The curve reveals of the occurrence of 2 magnetic transitions at 78 Kelvin and 95 Kelvin, which are further confirmed by the minimum of the derivative curve shown in the inset of the same figure. The figure 3 shows the hysteresis loop for the study samples. As it can be seen, typical hard magnetic behavior is observed over the entire temperature range below the ferromagnetic paramagnetic transition. At 2 Kelvin, under an applied magnetic field up to 4000 kA/meters, the sample exhibits a remarkably high coercivity of almost 2000 kA/meter. In addition, these ribbons display attractive magnetic properties, including a saturation magnetization of 1.45 teslas and remanent magnetization of 1.24 teslas, and high remanence radio of 0.86. This value exceeds the theoretical limit of 0.5 predicted by the Stoner-Wolfram model for the randomly oriented particles, suggesting strong magnetocrystalline anisotropy and possible texture in the ribbons. Finally, figure 4 shows the VH curve obtained from the hysteresis loop measured at 2 Kelvin. From this figure, a maximum energy product of almost 300 kilojoules/meters cubed was obtained, reflecting a strong hard magnetic character of the rapidly solidified alloy. In conclusion, This work presented the synthesis and magnetic characterization of rapid solidified terbium cobalt nickel ribbons. This alloys crystallizes in the tetragonal structure. The temperature-dependent magnetization measurement evidenced two magnetic transitions at 78 and 95 Kelvin. The hysteresis loop measured at 2 Kelvin demonstrates a remarkable combination of hard magnetic properties, including a saturation magnetization of 1.45 Teslas, remanent magnetization of 1.24 Teslas, high coercivity of almost 2000 kA over meter, and a maximum energy product of almost 300 kilojoules over meters cubed. Thank you very much for your attention, and if you have any question, don't hesitate to contact me by Huba or by email.